So I saw this picture on Facebook and I checked for the reason for failure. So from the picture you can see that the concrete already support is still in good shape, but the structure has been tilted to the left, which means that it has suffered from some kind of lateral loading, probably due to wind. Now, a bracing is a simple member of a structure that helps to resist lateral loads by transferring these loads to the support. Now, I'll use robot structural analysis to model something similar to this and then apply wind load to it, get the results, and then I'll add bracings to the structure and then apply the load again to get the results. Then I'll compare these two results and check how bracings helps to ensure the stability of structures where needed. So once you open your program, click on New and then click on Frame 3D Design. Now, if you are familiar with how to model on this software, you can skip to the end of the video where I show the comparison. But if you are not, you can follow up to the end. Now, click on Axis Definition at the top right corner of the screen. Here you can see that we have three axes, the X, Y, and Z axis. For the X axis, the initial position will be 0 and the number of repeats will be 2. The distance of each repeat is 1. That will make a total distance of 2 meters for the X axis. The number system is numbers for the X axis. Click on Add, then click on Y. Just like the X axis, the number of repeats will be 2, but the numbering system should be the alphabet. Now click on Add, then click on Z. The position is 0, 2, and the number of repeats here will be 4. That will give you a total height of 4 meters for that will be the height of the structure. Now the numbering system will be value. Then click on Add, click on Apply. You can then close this structure axis box. Now here, if you click on that home icon, you can see this. This is where we'll be doing the modeling. So let's create some new sections we are going to use for the modeling. Now click on Member section at the right side of the screen. As you can see, there is no section here because we haven't defined any. So now click on New Section Definition here, this white icon, and then for this project, click on this tube. So you can see family. You can see almost 5 to 6 families here. But we'll be working with the rectangular hollow sections. So click on this, and then for the section, the dimension that we want, that'll be let's use RHS 100 by 100. Alright, let's work with this. And then for the color, you can leave it at auto or you can just select any color. Now click on Add. That's the first section. Now the second section will also be a rectangular arrow section, but the dimension will be different. Let's use 50 by 30 by 2.5. Now change the color if you want. Let's use this. Now click on Add. The last section will be an end section. So just this end section, the angle section here. So let's use 25 by 25 by 4. Now continue the color as well. Then click on Add. I'll close this. Then close this. So let's continue by adding members to this axis. Now click on members on the right side of your screen. So change this member type to column, and then the section will be 100 by 60 for the 4 columns in the structure. So add a column to each of these corners on the axis. That's good. So in the picture, you can see that they used a pin support. So click on supports and then select pin supports. Add a pin support to each of these points and the axis. Then you can close this. Also from the picture, there are some extensions on all the 3 axes. They are not as we define at first. So let's just do some modification to it. Now on the x-axis here, I estimated a small extension to be 0.2 meter. Do not forget, it's just we are trying to get something similar to what's in the picture. It doesn't have to be perfect. So the position will be negative 0.2 since it is before 0. That's why it's negative. The number of repeats will be 1 and distance will be 0.2. And then the number system is 1 to 3. So click on add. The same for the last points we had before. So 0.2 meter. Then click on add. On the y-axis, do the same. Before the positions 0.0, you should have negative 0.2. The number of repeats to be 1, and the distance to be 0.2. Before you click on add, change this to the alphabet. Click on add, and then after this 2.0, click on add 0.2 meter as well. So click on add. On the z-axis, we are going to increase the height by a distance of 0.7 meter. So click on the last position we had before. Then click on the number of repeats, increase by 1. The distance is 0.7. Before clicking add, make sure you change this to value. Then click on add. Click on apply. You can then close this. So now for the upper part, click on members again. Then change this member type to beam. Make sure you are still working with the 100 by 60 by 3. Now let's add some members here. Now this is fine. Now change this to RHS 15 by 30 by 3 for the perimeter of the upper parts. Can zoom in properly to avoid any mistake. So also we need to add some members here using the same section. And also on these 4 sides. Alright. Then if you look at the picture again, there are some beams at this center here. Let me close this. At this center here. So if you click on this nodes number here, you can see that at this section that forms the perimeter, we have 4 nodes. This is 1, 2, 3, 4. But to design this inner beam, I'll have to divide all these perimeter sections into at least 4. To do that, click on any of the sections, then click on edit, then click on divide. You can see here that you can divide using 4 options. But let's divide into the number of parts and then type in 4 inside this place. Click on execute, then click on, you can see that 3 more nodes have automatically appeared here. Now click on the other sections that forms the perimeter to design that. You can then close this. So now let's add some members across the newly created nodes at the middle. So by using the 100 by 60 by 3, now add the member here. And also one will be here. Do the same for the other side. Also, we have to add some vertical members at each side. So change this to 50 by 30 by 3 and then add the vertical members. So once again, it doesn't have to be perfect. You only want something similar. I think that's fine. Now if you click on the section shape, you can see the shape of all the sections here. But we need to rotate all of these middle RHS sections. So click on geometry, then click on properties, click on gamma angle. We use gamma angle to rotate. Now we want to rotate by 270 degree. Click on member lists and then click on any of these middle sections, then click on apply. You can then click on all of the sections at the middle to rotate all of them. So that's all. Close this, then click on all. Switch off the node, and that's fine. Now let's clad the top so we can apply a load due to the water, the liquid in the water storage tank. Now click on geometry, then click on claddings. So since it's a rectangular shape surface, click on rectangle. You can also use contour if you like. Now switch off this section shape. So now we can apply a surface load to the surface. Now close this. To add some brackets to this design here, we need to divide the columns into at least 6 nodes. So go to edit just like before, click on divide. Now we'll be dividing into 6 nodes. So click on each of these columns here, and you can see it has been divided. For the brackets, we'll be using the last section we created, which is the L section. So click on members and click on 25 by 25 for the L section there. Now add brackets to it. You should zoom in properly to avoid any mistake. So this is good. So now let's go to loading. From the picture you can see that there are only 2 nodes on the surface. The first one is the load due to the water in the storage tank, which is going to be applied on this surface here. And the second is the wind load, and that is going to be applied laterally to each of these members in the design. So click on load types, and then the nature here is the default nature is dead. So select that. Now the initial dead load, which is symbolized with TL1, is going to be the self weight of the structure, and that's why this changes to red when you click on add. So the second dead load will then be for the load due to the water in the storage. Now click on add again. So the last one will be for the wind. Change this nature to wind, and then click on add. To apply value for each of these loads and also select mode of application, click on load definition, and then change this to DL2. Because DL2 will be applied on the surface, click on surface and then click on uniform planar load. So keep the X and Y axis, the value for the X and Y axis to be 0, and then the value for the Z axis should be negative because the load is in the negative direction, is in the downward direction. So let's have negative maybe 8.5 here. So click on add, apply to, this has been selected already, then click on apply. As you can see, this has been applied. This is the load on that surface. Now for the wind load, select wind 1 here and then change this to member. Click on members and then click on uniform load. Now here you can either apply the load in the X or Y direction, but keep the Z direction to be 0. So let's use the X direction here, and we'll be using a value of 4.3. So click on add and then apply that to each of these member, each of the member in the structure. Now let's combine the loads. Click on load and click on manual combination. So here you can move all the load at once by clicking on this two arrow, or you can have them individually by clicking this. Now here, if you leave the factor at auto, the program will give you random factors, but you can change it if you want. So move the date load and the when load. You can see they have different factors. I'll click on apply. So you can then close this. Here you click here, you can see that the combination has been added to the load list. So click on this. The when load and dead load have been combined. So now click on calculation here. Now let's go to results. So click on results and then click on diagrams for members. What we are trying to do here is that we want to see the deformation of the structure if there's no bracing in it, like it is in the picture. So go to deformation and then click on exact deformation for members. Click on apply. You can see the deformed structure has now appeared. So let's get rid of the original structure by clicking the deformation displacement tab here, and then also get rid of this to see the deformed structure alone. And here we're having something similar to what's in the picture. And if you want to see the magnitude of each deformation, click on parameters and then change this to label and then click on apply. Here the number in red is showing the member with the maximum deformation, and it's also displayed at the bottom here, while the number in green is showing the opposite. Now this result, now we're going to compare this to what we get after we had bracing to the structure. For the reaction, go to reaction and then select all of this and make sure all these are selected as well. So click on apply. As you can see, these two reactions at the back are acting downward, and that's because they're trying to keep the structure on the ground, and these two here are acting upward. That means they are trying to keep it off the ground to oppose the combined load. So let's add bracing and check and compare the results. We are going to be using the L sections for the bracings, but first let's get rid of all this. So click on members and make sure the L section is selected here. At the height of 3 meters on the axis, add the L sections across the columns, something like this. Then from these points to the node that supports here, add a member there too, and also on here, so that they cross each other. Do the same for the other side. So these diagonal-like sections are what we call bracings, and they help to resist lateral deformation due to wind or any other lateral loading out there. So in some design, they may choose to add them even to this to other side to resist any lateral loading from any direction at all. So this is what we call a bracing. Now I'm going to run the calculation again to see and get the result. Then we compare this to what we got before. Click on calculation just like before, then go to results, go to diagram for members, and then to deformation. Select the exact deformation for members, go to parameters and change this to label. You see here that we have a maximum deformation of 75. If you compare this value to 3064 that we had before, you can see a significant difference between the two. So this is how bracing helps to ensure the general stability of structures that are easily affected by wind or any other form of lateral load. So what's happening is that the bracings are transferring the load, the lateral load, to the supports. So this is perfect. I mean, the difference is just to play.